students, welcome back. So now we're going to kind of move on to the next part, which actually let's go ahead and open up our books too. So I'm going to open up our book, and right now we should be taking notes. You can go ahead and write down in your notes 9-3 similar triangles. So last chapter we talked about just similar polygons, anything that has multiple sides. So basically anything that's not a circle, as long as you have at least two sides, you're a polygon. But in this chapter here, we're going to focus primarily on objects that have three sides, okay? And basically before, what I would have you do is make sure that the two, or the at least the two objects that you're comparing, have all the angles that are the same and all the sides that have to be essentially all the sides have to be proportional to each other, or make ratios that are proportional to each other. Well, just like you've learned before with side congruence, or so if you don't know what I'm talking about, when you are trying to prove triangles had to be congruent, I mean the same in almost every way, in terms of the sides have to be the same, as well as the angles, all the angles. Well, how you proved two triangles were congruent were as follows in these techniques. If you knew that you had all three of the sides were the same on both the triangles, this would prove that they were congruent. Or you could say, if you knew, not necessarily, you didn't have to know all the sides were congruent, you can also say that if there's a combination of a side sandwiched with an angle and a side that were congruent to just another three things on the other triangle, the side and angle sandwiched between another side, if you can prove that by SAS, you could say that these two triangles were perfectly congruent. That's all the pieces you would need. You don't have to prove that every single angle and every single side was the same. That'd be a pretty tough thing to do for every situation. Sometimes you only need three bits of information. Side, angle, side are the same on both triangles. Then they're both congruent. Another way, if you remember, was angle, side, angle, which would have been, if you could have proven that the corresponding angles and sides in this way, that there's an angle, a side, and an angle that would be congruent to another angle, side, and angle in a corresponding way. The same angle and then the same side and another angle are congruent on both triangles, then the rest of the triangle would end up being completely congruent. You'd use, I think there's another one too, but I completely forget. Let's see, yeah, it doesn't come across my mind, but we at least learned three different ways to prove that two triangles were perfectly congruent. Well, in this case here, we're transitioning to not congruence, but like I said, this is different from similarity. So let me go ahead and close this really quick. The first way is really easy. You can see that if you can prove that at least two of the angles on two triangles are congruent, they are congruent, okay? So let's say in this case, in these two triangles, that this triangle, angle A and F, are congruent, and then B and G are the same and congruent, then both of these triangles will end up being similar, not congruent, I'm sorry. So that means that their triangles look proportional to each other in size. They don't necessarily mean that they're exactly the same size, but we can say that if at least two angles in a similar order, corresponding order, are congruent to each other, then you have two triangles that will end up being similar. So that's what that similarity sign says there. Again, you can make a cheat sheet where you can put this similarity theorem on there if it helps, but it's pretty simple. So let me give you an example where we can test that to see. Let's test this theorem out and prove it to ourselves. Or not necessarily prove it, but let's just see if it works out. So here's your first example, and it's going to be using, so right now your notes might say 9-3 similar triangles. All right. And the first kind of subtopic would be using the AA similarity postulate. And then here would be an example. You have two sets of triangles in this way. 1, 2, 3. That would be LJK. And the corner here would be 57 degrees, 48 degrees. And on this triangle over here, okay, again, you can't really tell if they're perfectly congruent or heck, if they're even similar. But I'll give you the angle measures, and that's all we can judge this piece on, or these triangles here. I want you to determine whether these two triangles are similar or not. And you don't have to pause this. I'm just going to continue on. So I don't know if you could see this. Oop, let me see. I don't know. Oh, I think I'm just changing the lighting here, but let me focus on that really quick. These two triangles are as follows. This angle measures 57, this is 48. However, on this triangle, all we have here is 57 and 75. So are these two triangles going to be similar, yes or no? Well, let's double check and see. And we actually should be able to tell, based on our general knowledge of triangles. Ask yourself, please, what do all interior angles of a triangle have to add up to? Well, they have to add up to 180 degrees. So meaning this triangle here, if I can back out now, right, let's see here. The only angle measure that we don't have is K. So we'll say we can actually write out that angles J, technically it's the measure of the angle, if I had to be technically correct. The measure of angle L and the measure of angle K all have to add up to 180. And I could substitute, that's 180, sorry about that. I could substitute in the values for the measure of angle J is 48 degrees. Measure of angle L is 57. And the measure of angle K is unknown, so I'll just leave it as measure of angle K, kind of like a variable, 180. And if I do some math here, let's see, 48 plus 57, that should be, I believe, 105, if I'm correct here. Let's see, yes, that's 105 plus the measure of angle K is 180. Then I subtract 105 from both sides. I will end up getting that a measure of angle K is 75 degrees. So this should be 75 degrees right here. Measure of angle K is 75 degrees. And if we look closely, both the triangles should be similar. Why? Because you have 57 degrees in the corner here, and you have 75 degrees, with these two angles alone being congruent to another pair of angles on this triangle. Then by definition, these two triangles should be similar based on the definition or the theorem that we just talked about here. Two angles being let's say a pair of angles being congruent on one triangle to the other, then they're similar. They're proportional. Everything's proportional. The sides are proportional to each other. Okay, but let's just prove that. So I don't know if we're convinced. So let's just double check on here. The same thing here. All the angles have to add up to 180 degrees. Let's write that out. The measure of angle M plus the measure of angle P plus the measure of angle Q all have to add up to 180. The only things that we know so far are that measure of M is 57, the measure of P is 75 degrees. So let's go ahead and substitute that in. 57 degrees plus 75 degrees. We don't know the measure of angle Q. Let's just ask ourselves, what do we expect angle Q to be? Well, if these two triangles have to be similar, all the angles should end up being the same. We have 57, 75, 57, 75. Let's guess that the other one should be 48, because they should all be congruent if both of these triangles were to be similar. But let's see that. So 57 plus 75 should be 130 degrees if you do some quick math there. Let's see. Oh, no, you know what? It's 57 and 75. So I don't have white out with me, so let me write that out. So that should be 100 and, let's see, if someone caught that, thank you. I thank you. You would have corrected me in class, so I'm thinking ahead of time right now. So you subtract 132 from both sides. And if you check your math, okay, through your own handiwork, or heck, even a calculator if you wanted to, the measure of angle Q does indeed end up being 48 degrees. So if you look closely, all the angles end up being the same. And simply put, we only knew that two of the angles, 57, 75 initially, in the order that I saw for them, those were the only angles that I knew at one point to be the same. And it made the whole triangle similar. But just to double check, I just double checked the third side, 48, to see if it was the same as the other triangle. And it was. So all the angle measures ended up being the same, but all I needed were that two of the angles were going to be the same. Okay, so let me give you a sample problem that you can try with your partner. Now, if you're in class, you can choose to do one. You can all choose to do one right now, so you can all talk to each other like, hey, do we want to do this, or do we just want to keep moving on to the next set of notes? Because these videos are going to add up being very long, I think, to cover all the sections. Okay, so it's up to you guys if you guys want to do this one or not. But I'm going to go ahead and write, like, I'm going to draw, let's see, two parallel lines, right? So I think I'm going to draw here and here. These should be parallel, right, the way I drew them. Okay, and what you're going to do is you're going to take a vertex here and connect it to the other vertex, the other opposite vertex on the other line. You're going to make essentially two sets of triangles with parallel lines, and then I'm going to call this RST, X and W. And I want you to determine if is triangle, let's see, RSX similar to triangle RSX WST. So that'll be your task the next few minutes. So please go ahead and work with the partner if you would like, or you can skip on to the next video to see what to do or what notes you can take. But go ahead and work on this if you'd like in class, okay? Pause this and then unpause it when you're ready to look at the answer. Okay, all right, so you should be unpausing the video now just to check your answer. And let's see, they should actually be, yes, the answer is yes. The answer should have been yes, but let's see how. The first thing that we needed to see is, or the only thing that we know to make, the only rule that we know to make two triangles similar are that you can prove that at least two angles are congruent on both of the triangles. Making the triangles at least similar and proportional to each other, not perfectly congruent. The reason why I knew the first giveaway is that there's vertical angles. There's angles on opposite sides of each other, kind of like crisscross from each other, making them vertical. And we know no matter what angles there are, any two angles vertical to each other are always the same. So this angle on this side right here should be similar to, or I'm sorry, exactly the same as the other angle opposing from it. No matter what I do to the crisscrosses, the angles end up being exactly the same across from each other. So there you go. Because of vertical angles, I have an angle on one triangle being congruent to the angle on another triangle. That does not fulfill the requirement just yet. But if you remember, if you can't see it, because these are parallel lines, this requires you to have some information on about 2 or 3 sections ago. If you have two vertical lines, or two parallel lines, you can kind of extend this together out a little bit. I'm doing it in different colors. So imagine this extends out. And you have a transversal. You can do it for any of this line from R to W or X to T. You can do it for either or. But you can look at it as the angles on the interior, on the insides of the triangle, are the insides of the parallel lines, and alternating, meaning that they're not on the same side. This is on the lower side of RW, and then this is on the upper side, so they're alternating. Through alternating interior angles between two parallel lines and what we call a transversal, you might recognize that you have alternating interior angles that are congruent. Okay? So angle R and angle W should be congruent to each other. So let's first do this one. Angle RSX, angle RSX, we know to be congruent let's see, WST because of vertical angles. Okay, you can say that as like one statement. We're not writing this as a form of proof. We're just writing it to ourselves that we know that because of the vertical angles. And then we also know that angle, let's see, XRS in that order, or you can just say angle R in this case. I don't know what you're talking about. Angle R in the corner right there is congruent to angle W because of the alternating interior angles theorem. And you can say the same thing for these two angles here. You have angle T. I'm going to write this in a different color with 3 dash marks, indicating that only this angle we know for sure is going to be congruent to this alternating interior angle, again, sandwiched between two parallel lines and a transversal. And on the inside of these triangles, these angles in the triangles, on opposite sides, like here we have like above this line of x to t, this transversal line of x to t, right below the line of x to t, alternating up and down, these are going to be congruent. So again, through the same thing, I'm going to say number 2 in a different color, angle x is congruent to angle t because they are, again, through the alternating interior angles theorem should be proportional. So again, we only need 2 of these statements to work. We only need 2 sets of angles to work. But we can also say, just further along, we have proven that all 3 angles will end up being congruent through the same theorem, alternating interior angles for at least 2 pairs of angles. So basically, we only needed two angles to prove that these 2 triangles will be proportional to each other, but we have a third side, or we have a third angle. We just proved, in fact, that yes, both these triangles will be proportional to each other if you kept exploring, but you only need to prove that 2 of them are congruent to each other in order for them to be similar proportional shapes. Okay, let's go ahead and stop there, and then I'm going to go ahead and go on to another topic, or within 9-3. So we're not finished with 9-3 at all. Okay, guys, thank you guys so much. Let me see if I can stop.